If you studied maths in university, this might be obvious to you, but I know from helping people with maths that at second level, like teenager 13 to 18 or so, this isn't as obvious to people, but it really is so helpful for understanding. So if I were to write, for example, 3 meters, 3m, most people know what that means. It just means 3 meters. It's a certain length. But what they don't know is that the word meter is exactly like any other variable. If I wrote 3x, that means 3 x's. Writing 3 meters is the exact same thing. That's the same as saying a meter plus a meter plus a meter. It's 3 meters. And what does that look like physically? Well, if this is 1 meter, then 3 meters is just that added 3 times. So you get 1, 2, 3. That's what 3 meters are. They function exactly the same as anything else in maths, any other variable. They're just a specified constant length. Like x could mean a certain number, and 3 of those x's is certain, 3 times that certain number. It's the exact same for meters, which seems obvious, but a lot of people don't get that at second level. And why is this useful anyway? Why would this matter to you? Well, where it really comes in handy is when you're converting units. So a lot of people learn off by heart that to go from centimeters squared to meters squared, you multiply by like, I don't know, 100. I don't actually know off the top of my head. It probably won't be 100 because I do it this way and I just think it's makes a lot more sense. So 3 centimeters squared, remember that this means something. It's the exact same as anything else in a kind of algebra. And what we do know, well, what you should know is that 1 centimeter, or I guess you could say 100 centimeters, is equal to 1 meter. That's just something that you can know, because centi means 100. So if you have 100 centi, or 100th, sorry, centi means 100th. So 100 times 100th gives you 1. So that kind of is what that prefix means. And we know that this is true. And then if I solve for cm, because I want to replace this cm here, I want to replace that with m. Now it's important here, cm is kind of like a fixed thing. It's not c multiplied by m, and then m is also. So that means that a centimeter is equal to 1 over 100 meters. Okay, and that means what I can do here is I can say 3, and I can replace cm squared with 1 over 100 m, and that's what cm is, so that whole thing is going to be squared. And this is just such a more intuitive way of doing it than trying to memorize, oh, multiply by 10 to the 4, which I've realized now is not 100. Because now what you can do, and this gives you practice with the laws of indices, this is just one, but if you don't know the laws of indices, you can just write this out twice. That's what squaring means. So you have 1 over 100 meters. And then what you get is you get 3. And then, okay, so 1 over 100, that's, or 100 times 100, sorry, that'll give you 10,000. Yes. And then a meter times a meter will give you meters squared. And then obviously we want our answer in meters squared, so we can just rearrange this fraction. We have 3 over 10,000 meters squared. And you can see we've converted there without trying to memorize anything. Of course, once you get used to it, then you can memorize it's just dividing by 1,000, because normally you multiply by 100, but we're squaring it, so it's 1,000. But then another thing that people also find quite difficult is, do I multiply by 1,000 or do I divide by 1,000? And in this example, it's very obvious because it's meters and centimeters. But later on, I'm going to show you an example where it's not as obvious and this method really does come to save you. So where this method is particularly useful is when we have units that don't make too much intuitive sense. For example, 2 units of energy, and don't worry, you don't need to know anything about physics for this, are the electron volt and the joule. And they can be converted like this. And it's not incredibly obvious here. Would I multiply by that? Would I divide by that? Or at least to a lot of secondary school physics students, it wouldn't be obvious. So here's what we can do. 300 joules. And we want to convert it to electron volts. So we need to replace this J with something. So what can we do? Well, here we can solve for J. And we can say J equals EV over, and then this big number, which I'm going to copy. And then what we can do is we can just rewrite 300 and then replace J with this thing, EV over, and then we take this. And then all we have to do is we will just want it in terms of electron volts. So all I have to do is I have to just combine these two numbers, because multiplication is commutative and division kind of is, like this 300 over 1. So we can just multiply the two fractions and then leave the EV, because we just want it in terms of electron volts. We don't want it in terms of electron volts per whatever. And then once you put that into your calculator, the 300 over, you get like 1.87. Again, I'm not doing a bunch of decimal places, times 10 to the 21. And then we still have the EV, and boom, you've converted it, and you haven't had to memorize anything. And again, this might be really obvious to some people, but in our physics class, we were told if you want to convert from joules to electron volts, you divide. If you want to do the other way around, you multiply. And it's not too hard to remember, I'll admit, but like when you're doing that for multiple, like if you're doing that, you have to learn that for a bunch of different units over a whole 2-year course, it really starts to get confusing and difficult. One more example, 19 electron volts. This one's a lot easier. 19, we want to convert it to joules. What is EV equal to? It's equal to this. So we can just multiply, we can replace EV by this, and then we can just simplify this. And when you do put it in your calculator, you get 3.04 times 10 to the minus 18, because we just use multiplications commutative. We did these two together, combine these two, and then we just have joules. So that's a really easy way to convert things.